So as we have our vectors, we need to consider the properties of some certain shapes, which is going to help us in the calculations if you understand the shape that you are given. So I want us to just consider, let's say we are given a parallelogram. All right, let us just consider a basic shape. The properties of the shape of what we are given being a parallelogram, let us say we've got something like this, all right, where we have got A, B, C, D like this. We know that opposite sides, they are parallel and equal. So meaning to say this part being parallel and equal. This side being parallel and what? Equal. It is the same concept that you are going to apply under vectors. You're working with the vectors. So when you are given a shape, you consider its properties. You consider its properties. So let's say we're given A, B, C, D is a parallelogram where vector AB is given as vector A, and you're also given the vector BC, which is given as B. From the properties of the shape, knowing that you're dealing with a parallelogram, you're going to have something like this, all right? This is what you're going to have. A, B, C, D. The naming here is in your hands. A, B, C, D, or you're going to have it A, B, C, D like that. All right? So let's say we've got A to B. From this presentation, A, B, and this DC, they are parallel and equal. So from the vector concept, these arrows are supposed to face one direction. They're supposed to be facing same direction in this case. A to B, D to C. These two are parallel. Because of the properties of the shape, it is not just parallel, but also they are what? Equal. So in terms of the vector now, since we are given as a vector AB, we are not given to say AB is 5 centimeters, then this is 5. You are given the vector representing A to B, which is what? Vector A. So it follows that it is the same as D to C. In vectors as well, it will be the same. So same concept here, BC and what? AD being parallel, this BC and AD. They are not just parallel, but they are also equal. So in terms of vectors, you indicate the the arrow from B to C, which represents vector what? Vector B. So automatically vector AD is also B from the concept that opposite sides are parallel and equal. So that is where the property of a vector plays a role. Property of a shape. So it's actually the properties of what? Shapes. You are working with a rectangle. You know that opposite sides are what? Equal. Not just equal, a rectangle is a parallelogram. So meaning to say these sides, they are parallel. Opposite sides are parallel. So same concept, just like what? A parallelogram. So from that, you can also determine any vector that you might be asked from what you're given. Let's say you want to find vector AC. You can take any direction to find that AC. So you need a route that you're going to take. Let's say you take this one, A to B, then B to C. So you write down the route. I move from A to what? To B. Then after that, I'm going to move from B to C. So take note, it's vector AC. Your starting point is A, that is the same starting point here. The end point is C. It must be the same end point, which is C. And these two in between, they must be the same. This is B here. This is also B. If these two guys do not connect on your addition, if these two do not connect, then it means you are writing that root in a wrong direction, in a wrong way. You're supposed to have those connecting B and B being the same. So vector AB, I have it A to B. That's our vector what? Our vector A. You write what is there in terms of the direction. So if you take your vector if you take this root in the same direction as the arrow on the diagram here, the arrow is facing this way. AB is also facing the same way. As are we seeing the arrow and the direction is the same. So it remains a positive. The same thing here from B to C. Are we seeing that our root BC from B to C, we are going this way. It is the same direction as the arrow that you're given. So it maintains that positive. It remains what? As a positive. So I want you to see this one, the way where it can be a negative. All right. Where it can be a negative. Let's say we are being asked to have the root CA. All right. Let's say we want to find CA, vector CA. And we took it from what we had here. All right. We want to take it from this one so that we can properly see what I'm trying to say in terms of what? In terms of the direction of the root. C to A. Let's say we want to do it by what? Calculation from this diagram. We're going to move this way from C going to A, or you can even move this way from C this way to A. It is in your hands. So I want to take this one. From C going to A, taking C to what? To B. All right, we are going to move C to B. We are moving. On the root, you add. This is the root that you're going to take like. So you just add whatever that you're having there plus. B going to what? To A. So on the root, there is no negative there. You just take them as what? Positive as they are. So I want you to see the same concept. You started with C. This is the same C. Our end point is A. Our end point here is what? Is A. And these two, they do connect. This is a B and this is a B. All right. So if you are going to consider that vector now, all right, from C to B, I want you to see what is happening. We are going this way, C to B. This is our root, C to B. But what is presented on our diagram? It is a vector BC. The arrow is from B to C on our diagram. But as we are moving this way, we are opposing the direction of what the arrow, the direction of what is on the diagram and what we wrote here is opposing. So that becomes a negative whenever it opposes. So it will be negative vector B. That's where you indicate the sign, not here. You indicate the sign on the vector that is representing what? The root that you took, C to B. So it will be negative B. The same thing, B to A. From B going to A, we are moving, going this direction. This is where we're going. But look on the diagram. The arrow is going another way, opposing. So that's a negative as well. So it will be negative vector A. So that's the concept. So it is simply minus A minus B, starting with this A, that's negative A. B is also a negative. We are just rewriting from what we have. We haven't, we didn't change anything like crossing the equal sign where this was this. No. So they remain with their negative values like that. All right. So I wanted you to see where the negative is playing a role when the direction, the route that you are taking is opposing the direction that you are given from the diagram. It opposes. That becomes what? A negative whenever it opposes. of which we could have just calculated CA from AC. Let's say it is something under exam, they ask you to find vector AC. Then from there, you are being asked to find vector CA. You can find that vector CA from AC. Remember, it is simply a negative of what? AC. You have that AC just opposing from A to C as we are now going this way. So simply multiply that vector AC that you obtained by what? A negative. So you're going to obtain the same answer, negative times A, that's negative A, negative times B, that's negative B. So we can see it is the same answer as before. So that is the concept that you're going to have. All right. So here I just want you guys to know the properties of the shapes. All right. If you are given that it is a square, it means a square, guys, all sides are equal. What are you given? Is it a trapezium? No, the properties of what? A trapezium, where we only have one pair of what? Parallel sides. So meaning to say, on that concept of parallel sides, there is a relationship between the vectors. If this is a vector A, then this one is going to be K times A. It is the same vector A, but just multiplied by a constant. That is the concept that you are having in this case. They are not equal, they are just parallel in this case. Not equal, but what? Parallel. So that is the concept of what? Parallel what? Parallel vectors. All right. If two vectors are parallel, let's say this is A, B, C, D, and we are given in this case, BC is parallel to AD. So this one indication for what? Parallel lines, or you can have it like this, all right? You can have it also like this. A, B, C, and what? AD being what? Parallel. It follows that we can write BC in terms of AD or AD in terms of what? BC in terms of a constant, with a constant, I mean. So BC can be written as KAD, where K is a constant. Or maybe it was AD written in terms of BC, K, BC, like that. It can be given in any way. So for parallel vectors, a constant can be multiplied to 1 to obtain another one. So if these two are parallel, that is the condition that they will give you. So it's just about the properties of the shape, right? Is it a triangle, an equilateral triangle, an isosceles triangle? What type of a triangle are you given? If it is an isosceles, you know that two sides will be what? Will be equal. So know the properties of each and every shape. And also other shapes, like is it a regular, those regular shapes, a regular hexagon, considering what? Polygons, any polygon. You must go through regular polygons, irregular polygons, but mostly they can ask about regular what? Polygons. Is it a hexagon, a heptagon, an octagon, a nonagon, a decagon? Know the properties of each. That can help you to answer those questions, all right? So from this one, I want you to check, go through the videos in the playlist, all right? So you just go through the playlist up to the end so that you can understand how to attempt these questions on what? On vectors. So I'm going to work out examples considering what? The properties of the shapes, all right? So already there are some videos that are there, so consider those ones as part of revision. This is just a basic for you to understand what follows, all right? So go through those to understand in terms of what calculations now, as you are to do the calculations on the properties of the given shapes. Then I'm going to have another class with you guys referring to some special cases, just like here, working with the properties of parallel lines, working with collinear vectors, collinear equal vectors, and so forth. Then it is exam. From there, let us do revise as many question papers as we can. All right. If there is any question that you do not understand, that is where we have the comment section. Let us communicate on the comment section. If you do not understand any part in your revisions as you are preparing for your examinations. All right. So that is it till we meet again.